Hi guys, so in this video I'm going to introduce you to the arithmetic sequence or arithmetic progression, and then we're going to look at an exam question together so that we can see how all the things I'm going to show you at the start, how these things come into life when we look at an exam question. So let me first start by introducing to you what an arithmetic sequence is. So an arithmetic sequence is a sequence whereby you have a common difference. So let me create one for you. So let's say you have this sequence here. All right. So we can see that in this sequence, each number is being increased by 2. There's a difference of +2 between each number. All right, so the common difference is equal to 2, and the common difference is called D. All right, and in the first term is called A. So A also happens to be 2 here. Sometimes we call it U1. All right, so there are two key things for an arithmetic progression. The first thing is that it has a common difference, meaning if you need to find t, you basically need to do un minus 1, where un is a term and un minus 1 is a term before it. So if I take the second term here, u2 minus u1, that means second term, which is 4, and first term is 2, so we get a difference of 2. In the same way, we can do u3 minus u2. We're still sticking to the formula un minus 1. So u3 minus u2, that would be the third term, which is 6, minus the second term, which is 4, and that still gives me 2. So in an arithmetic progression, you take any term and you subtract the term before it, you should get the same number. Okay, and that's why it's called a common difference, because it's the same difference we get over and over again. All right, so this is how we calculate the common difference. We take un, any term, and you subtract it to a term before it. What else do I need to tell you? So we have a common difference, we have the first term, and what happens in exams is that sometimes they ask you to find sum of first n terms. So sum of first n terms is referred to as Sn. Okay, so Sn is sum of first n terms. All right, this is called Sn, and the formula for it is n over 2, 2a plus n minus 1 d. So that's the sum of the first n terms. All right, let's try it. So let's say you have to find the sum of the first 4 terms, sum of the first 4 terms. So you'll need to do 2 plus 4 plus 6 plus 8 to give you the sum of the first 4 terms here. What do we get? 6 plus 4, and that's 10. 10 plus 2, 12. 12 plus 8, that's 20. All right? So let's say we had to use the formula here. We're going to use this formula. So Sn, so S4 is equal to n over 2, so that's 4 over 2, open brackets, 2a, so a is the first term, which is 2, plus n minus 1, so the n is 4 here, 4 minus 1, 3, d is the common difference, which is 2. Let's see what we get. So 4 divided by 2 is 2, 2 times 2, 4, plus 6, what do we get here? We get 20, because 6 plus 4 is 10, 10 times 2 is 20. So we end up getting the same answer as we previously got, where we actually added the terms. So the sum of the first n terms is denoted by Sn, and it can be used in questions. Now, this is a very straightforward question whereby the terms are given to you and we're just playing with the terms, and I'm showing you how we can find the sum, find the difference. We can actually use the sequence to predict terms also. So I've showed you the difference d. I've showed you the sum of the first n terms. One more thing you need to know is how do you find a term in general. So the general term un is a plus n minus 1 d. So that's the general term of an arithmetic progression. So let's say we use this formula to find the fifth term. I know we already have the fifth term, but just to show how it works, u5 would be a plus 5 minus 1, which is 4d. So a is the first term, that's 2, plus 4 times d. My d also is 2, so what do I get here? It's 2 plus 4 times 2, 8. And that happens to be 10. And is my fifth term 10? 1, 2, 3, 4, 5. Yeah, it is 10. So you can see that all these formula actually work. So now, next we're going to do something exciting. We're actually going to look at how an exam question looks like. Okay, but before we do that, I'm just going to clean the board for us so that we can focus on the exam question. What happens during exam is that the questions are not that direct, and they actually give you information in the question. You need to highlight the key information and then create equations out of the key information. So let me just browse through the desktop and we're going to look at the question. So on the screen here, or in your case on the board here, we have a question which we got actually in an HL paper. Okay, May 19, AHL DZ2. So that was in an HL paper, but this kind of question is actually relevant to the SL syllabus as well. So let's look at the question. It tells you that in an arithmetic sequence, so we already know it's arithmetic, we don't need to guess here, the sum of the third and eighth term is 1. So this information can actually be converted into an equation. So sum of the third and eighth term is 1. So I'm going to write the third term plus the eighth term, that gives me 1. Okay, that's my first equation. And then I go back to the question. Given that the sum of the first 7 terms is 35, so sum of the first 7 terms, so that's S7 is equal to 35. You see, I kind of extracted the 2 key information. All right, let's go back. Determine the first term and the common difference. So I need to find A and D. So I'm going to write down on paper, A is equal to question mark, D is equal to question mark. So they've given me two pieces of information, and then they asked me to find 2 unknowns. So that should remind you of the simultaneous equation, whereby they give you 2 pieces of information which will convert into equations, and then you need to solve them. So let's see, what can I make out of the first one? U3. So you can see that they're using terms here. So I actually need to use the nth term, which is a plus n minus 1 d. I'm going to use this formula. So U3 will be, if I use the formula here, U3, n is 3, you get a plus 3 minus 1d, and that's a plus 2d. All right? So a plus 2d plus u8. Use the formula again. U8 would be a plus 8 minus 1d, so that's a plus 7d. So I get a plus 7d is equal to 1. And then here we can group the d terms together. We can group the a, so a plus a is 2a. 2d plus 7d is 9d equal to 1. Okay, that's my first equation. I call it 1. Second equation is linked to sum. So we refer to our sum formula, which was n over 2, 2a plus n minus 1d. So my n is 7 here. So it's 7 over 2, 2a plus n minus 1. So 7 minus 1 is 6. So 6d is equal to 35. All right, and the divide by 2, I can send it there, it becomes times 2, so I get 7 2a plus 6d equal to 35 times 2, which is 70. And I can actually send the 7 also now. 2a plus 6d equal to 70 divided by 7, which is 10. And actually I can divide each term by 2, so I'll do that. I get a plus 3d equal to 10 divided by 2, 5. So that becomes my second equation. All right, and what we do from here is we try to solve them simultaneously. So I'm going to write these two equations, one after another. So a plus 3d is equal to 5. I can actually eliminate the a by first multiplying the second equation by 2 so that I get 2a. So the first one stays the same. You multiply by 2, you get 2a plus 6d equal to 5 times 2, 10. To eliminate a, I subtract. I get 3d is equal to minus 9. So 3d is minus 9, d is minus 9 over 3, which is minus 3, and from the d I need to find a. What's the simplest equation I can use here? I'm going to use this one, a plus 3d equal to 5 because it's simpler. So a plus 3d, so d is minus 3 equal to 5. So a will be 9 because 3 times negative 3 is minus 9. I send it there, it becomes plus 9 plus 5. And a is 14. So this is how I managed to get a and d from the equations I formed.